And welcome to 4.2 quadratic relations. So after 4.1, we've investigated what quadratic relations are. And so now we're going to talk about some of the key features on the graph, which you hopefully would have already seen a little bit from yesterday's investigation. So this point right here, in this case at the bottom of the quadratic, this is called your vertex. So this is either the highest point or the lowest point, which we call as max or min. So if it comes to a low spot, this is called a minimum. If it was the other way, that will be called a maximum. This opens down, and this parabola opens up. These are your x-intercepts. So note that this purple line here, that's your axes, your Cartesian plane. So that's x comma y. And so that's your x-intercept, or you can call it zeros, or you can call it roots. And same on this side right here, it hits the x-axis, so that's also the x-intercept. Here's another key point that you would also be able to recognize. This is your y-intercept. This spot here, the line, the dotted line here, that is your axis of symmetry. And it is exactly that. It is a line that would cut your parabola, your quadratic, in half. And this one here is your max or min value. So it is either your highest or your lowest spot. Notice that the axis of symmetry is always the x part of the vertex, and the optimum value or the max min value is always the y of the vertex. So you can also note, and I've already said the word, but parabola is another way to describe what a quadratic is. It is the U-shaped on a graph. So we've already mentioned that this is the shape of a parabola. Here are some key facts that you should know. Again, we've already talked about these opening up and down the roots. So the only one I'm going to mention are the last two, which is the form that a quadratic is in. This is standard form. So you will need to know this. The standard form is y equals ax squared plus bx plus c. And so anytime you see it in this form, you will know that it's a quadratic. The other way we can also tell that you are dealing with a quadratic is from a table of values. And the table of values, if you remember what the first differences were, you take the differences of the y values. Well, there's an example in a second, and we're going to be looking at taking the difference again, and these are called your second differences. To tell if it's a quadratic, the second differences will be equal, and the first differences will not be equal. So here's the example we're going to do. We're going to be filling in this chart right here on the right-hand side. Let me just get my pen. We're going to be filling out this chart here, and we're going to be doing it for this graph. So after, if you'd like, you can fill it in for these graphs. I'll zoom in and you can see it. We're only going to be filling in this section. So we have to decide what the vertex is for this parabola. And the vertex, again, is the highest or the lowest spot. So it's right here. And you always say it as x comma y. So this spot here is -3. And here is 5. So our vertex is -3, 5. Our maximum, or is it a maximum or minimum? If it comes to a high spot, it is again a maximum. If it comes to a low spot, it is a minimum. So this opens down, it is a maximum. The optimum value, the optimal value, or the max or min value, is the y part of your vertex. So this value would be 5. Your axis of symmetry should always be as an equation, and your axis of symmetry is where you cut it in half, and that equation would be x equals the value of your x in your vertex. The zeros, now these are just estimate because they don't lie exactly on here, would be about -0.75. And the other one would be approximately -5.25. So those are your two zeros, or your x-intercepts. The direction of opening, does this open up or open down? This opens down. Anytime you have a max, it opens down. And the y-intercept here is at -4. So you're taking the key features off of the graph, and you're filling the information on right here. So there are the other two if you'd like to fill out the charts for those graphs right there. We're going to move on to the next example where we talked about the first and second differences. So if a relation is quadratic, the second differences will be equal or constant. If the relation is linear, the first differences are constant. So if we look here at this table that's given, you take the y values, you take the bottom one, and you subtract it from the top one. So 6 minus 9 equals negative 3. And then you do the next two in line. 3 minus 6 equals negative 3. And you keep going. 0 minus 3 equals negative 3. And negative 3 minus 0 again equals negative 3. So because these first differences were all the same, we can conclude that it is a linear relationship. In this situation here, so we're going to follow the same steps where we're going to be taking the differences of the first two y values, just like we did in the previous example, and then the next two, and then the next two all the way along. So I'm going to show the work for the first one. 0 minus 4 equals negative 4. The next one, 4 minus 0 equals 4. And then you continue all the way on. 16 minus 4 equals 12. And then you get 20 and 28. So as you can see here, negative 4, 4, 12, 28, and 28, these are not constant. These are not equal values. So then you'd conclude that so far it's not linear. And you'd go to the next step where you do your second differences. So you take the values that you got in your first differences and you do the same subtraction except with your new values. So this would be the bottom one, subtract the top one, 4 minus negative 4, and then 12 minus 4, 20 minus 12. And so if you look here, 4 minus negative 4 is actually 4 plus 4, which is 8. 12 minus 4 is 8. 20 minus 12 is 8. And 28 minus 20 is 8. And so you can see here that we have these values of 8 that are constant. Because those second differences are constant, we can conclude that this is a quadratic relation. So make sure you write all this down, and if you need to, you can go back and write these key features, the bits of information down, and if you have any questions, please bring them